Okay, this is Algebra 1, notes number 19, graphing using intercepts. Make sure you put your name, date, and period, and your essential question is how to use intercepts to graph equations. And to use intercepts to graph equations, you plot the x and y axis, your intercepting points on x-axis, and you draw your line. Okay, the x-intercept is the x-coordinate of your point that will cross the x-axis, and the y-intercept is the y-coordinate of your point that you're given, and it crosses the y-axis. So the y goes with the y, x goes with the x. So those are the vocabulary words on x-intercept and y-intercept. If I look at our first example, it says find the x-intercept and the y-intercept of this graph, and let me rewrite that over to the side. So I have 8x minus 2y is equal to 32, and one of the easiest ways I see to actually solve this is to separate this into actually two smaller problems, because I'm going to create a t-table here where I have an x and a y, and the x and the y intercepts will be written in this table. And a way to actually solve this is to say, okay, I'm going to cover up one of the letters at a time. So I'm going to cover up the y right here, and what you see on the left side is just an 8x, and on the right side you see 32. And so this is a smaller problem that you can either solve by hand and see that I'm going to divide by 8 and x will equal 4, or you can type it in your calculator, whichever you feel most comfortable with. Remember, in solving, I take the 8x and place it on y1, and I would take the right side and place it on 32, and then I'd have to go to the table, and then I would look in my table to where it has 32 on both sides, and if I zoom down to this spot, oops, there's 32 on both of those, and my x is actually equal to 4. So you can solve it in either fashion. But if the x is equal to 4, that means the y, when I cover it up, it's like putting a 0 in this spot, and 0 times 2 is just 0, and that's why I'm allowed to cover it up. So I'm going to say I put a 0 in for the y. Okay, if I do the same thing for the x, this time I'm going to plug in a 0 for my x. If I plug a 0 right there, 8 times 0 is just 0. So that's why I'm allowed to just cover it up and see the second problem. That is a negative 2y is equal to 32. So if you know your steps, that means you just divide by negative 2, and that'll be y is equal to whatever 32 divided by negative 2 is. If you don't like doing this problem, remember you can always go back to your calculator. And this time I'm going to put in negative 2, and I got make sure you always put an x, even though this has a y in my equation. The y2 is still going to be 32. If I go back to my table, I've got to look for 32. Let me scroll up. And right there at the top of my thing, I have 32 and 32, and my answer here is negative 16. So if the y is a negative 16. Okay. Now, this is in my table form, so it's okay. We're going to leave it there, because that's the way we're used to seeing it when we plot our points here in a minute. But because the 4 has an x and the y is 0, this is actually, I'm going to put parentheses around it representing a coordinate, and this is actually my x-intercept. The second one has the value in the y position, so 0 is first, and that one, the negative 16, is in the y position, so this represents my y-intercept. And I'm going to say this is our answer. It's written in a funny form, but that is our answer. Okay, if I go to these additional problem here, just to make sure you're understanding the process, I'm still going to have my table, so I have my x and my y table. So if I take in and I say, okay, I want to find the x first, so that means I've got to, basically I'm going to cover up, where'd my pen go? I'm going to cover up the y, meaning the y is a 0. If I cover up the y, my pen is too large, I need something smaller. Maybe I can take the penny. Almost. You see that I have an x equals 1? Well, there's nothing to solve there, so it just means x is 1. Do something a little bit bigger. Maybe I can use the edge of a scissors. Okay. If I go to the other way, I'm going to plug in a 0 for my x, and what is left here, it says y equals 1. So there's no real work on this one at all. It's just right there, given to you. So that means the first one has an x answer, so that's my x-intercept. And the second one would be my y-intercept. It has the number value. If I go to the middle one, on the middle term I have a little bit of work to do. I'm going to plug in a 0 for the y. In the x, I see this is negative 5x equals 20. So if I use the calculator for this, I'm going to put negative 5x into the y1. y2 will be 20. If I go to my table, I'm looking for 20. And 20 is right there on my screen of a negative 4. Realize you can still divide by negative 5. And then I need to do the 0 for the y. I'm sorry, 0 for the x, so that goes away. And then I have this secondary problem, 9y equals 20. And this one's not going to be so nice. If I was to plug it into my equation, 9x and 20, and I scroll, and I see that the 20 would exist somewhere between 2 and 1, but I don't know exactly where it's at. So for this, if I was to divide this straight, I'd have 20 divided by 9. So if I go to my normal screen here and do 20 divided by 9, I equal this big old long thing, and I don't want that big old long decimal, so remember to math frac it. Get it in the most simplest form, and for this one, it stays at 20 over 9. So we're going to label that as 20 over 9, and this will be our coordinates. Thank God we wanted to graph that one. So the first one will be our x-intercept, and the second one the y-intercept. Okay. The last one here, before we change and do something different, same process. I have my x and my y. I'm going to plug a 0 in for the y and a 0 in for the x so that I know what values I'm looking at. If I do the first one, a 0 for the y, I just cover up the y and I have 2x equals 8, which if I divide by 2, that means x is 4. If I cover up the x, that means I have negative 0.5y equals 8, and that one's not so nice. So if I go to my calculator and type it in, negative 0.5x, and the second one is an 8. And I go to the graph, I'm in the negatives, so let me go up. Oops, there it is. 8 on both answers is a negative 16. Okay, so there's my two coordinates, 4, 0 and 0, 16. First one is your x-intercept, and the second one is your y-intercept. Alright, on example 2, it asks you, now we want to actually draw the line using these intercepts. So with the x-intercept, remember this is the point that's on the x-axis. So the x-intercept is at 2, so go to your x-axis and go over to 2 and put a dot. That's a point that you have. And then the y-intercept is where it crosses the y-axis. So at 1, go to your y-axis is vertical, it's up and down, so at the 1, put a dot. And then you need a straight edge to draw your line. Use green. Okay. These are continuous graphs, so that means I need arrows on both ends of my graph. Otherwise it's discrete, and we don't want discrete graphs. And that's it. You're done. If I look at the second one, it has an x-intercept of -4, so where do I go on my graph first? Okay, x-axis, -4 is 1, 2, 3, 4, right there. And then the y-intercept is a 3, so from the origin I'm going to go up 3. And then if I draw my line for this one, make sure you add your arrows, and you're done. Okay, on the back of your notes we have 2 more last examples, and this one combines your 2 things you're just doing. From example 1 and example 2, it puts them together. So if I look at the first example, for example, this is actually example 3. They give me an equation. I'm going to write it larger. And they say, using the intercepts to graph the equation, graph this equation, label the points where the line crosses the axis. So they want me to place the points where the x-intercept and the y-intercept are. So this is written in the correct form. I need to realize for all of this, to do the intercepts, I did not specify it. These had to have a certain form. Notice your x and your y are on the same side. They have to be on both the left side to be able to do this type of setup. So that form is very, very important that we are using here. And on this example, it's still in the correct form, so I'm allowed to cover up my values and solve them. So I know I have the zeros. The first one I put the y being 0, then I have this equation 3.5x equals 14. And that decimal messes with me. I'm going to plug it into the y equals, and then go to my table, and I am, oh my goodness, gotta go to a 14. Oh, okay, there's my 14 on both of them, so my answer is a 4. So that means in my table, when the y is gone, the x is 4. Okay, and let me change pens. Let's go with orange this time. If I cover up the x this time, so it's going to 0, I have 2y equals 14, and I can see that one. Divide by 2, and y is 7. Okay, so here's your coordinates. Remember, the one with the x is your x-intercept, and the 7, because it's in the y slot, is your y-intercept. So let's plot our 2 points. X-intercept is at 4, 0. Put a dot. Y-intercept is at 0, 7. And now you need to draw your line. And make sure you have arrows symbolizing that it is continuous. Okay. Last example here. is not written in the correct form to solve this equation, but if we work with it the way it is, we can be okay. If I plug in a 0 for the y and cover it up, I get just x plus 6, but because there's nothing on the left side, I do need a 0. Well, if that looks scary, you can still go to your calculator and type in a 0 for the left side and x plus 6 for the right side, and then go to where your table equals 0. Here we go. I have zeros. On both of those, my answer should be -6. And then if I now make the x go to 0, if I can cover it up with something really skinny from Caesars, here we go, I can see that it says directly y is equal to 6. I don't have to do any math. Here's my two coordinates. The first one is which one? X-intercept. That makes the second one the y-intercept. Need to plot my 2 points. 0, -6, and then 0, 6. Go the y-axis and go up 6. And then I lost my straight edge again. Don't know where it went. I'm going to draw my line. And make sure you put arrows on the ends because this is a continuous graph. Okay. There isn't any independent practice problems, so make sure you answer your summary, which will be answering your question, how do you use intercepts to graph equations?